Welcome to the DIY Honda Garage channel. The DTC P2126 is a diagnostic trouble code specifically related to the Accelerator Pedal Position, APP Sensor B, which is also referred to as TP Sensor E. This code indicates that the readings from the APP Sensor B fall outside the expected range. The APP sensors are critical components in vehicles, as they provide input to the Powertrain Control Module, PCM, regarding the position of the accelerator pedal. This data is crucial for regulating engine performance, fuel efficiency, and emissions. The APP Sensor B is located at the accelerator pedal assembly in the Honda Fit, typically positioned under the dashboard. When this code is generated, it signifies that there is an issue with either the APP sensor itself or the wiring associated with it. The DTC P2126 indicates that the APP Sensor B is malfunctioning, either due to an internal fault or external wiring issues. The APP sensor is integral for translating the position of the accelerator pedal into electrical signals, which are sent to the Powertrain Control Module, PCM, for processing. This allows the PCM to adjust engine performance in real time, based on how much fuel to inject and the throttle response required. Typically, this sensor is mounted near the accelerator pedal, which is located near the driver's footwell under the dashboard. When readings from this sensor fall below 0.2 volts or above 2.51 volts, the PCM interprets these as out-of-range signals, triggering this error code and placing the vehicle in a safe mode to prevent potential engine damage. Several possible causes may lead to the DTC P2126. A faulty APP Sensor B is the most common reason, as internal failures can result in abnormal voltage outputs. Additionally, issues with wiring, such as open circuits or short circuits, can prevent the sensor from providing accurate signals to the PCM. Poor connections or loose terminals in the wiring harness connecting the APP sensor to the PCM can also contribute to this problem. All these factors can lead to miscommunication between the sensor and the PCM, disrupting the vehicle's ability to appropriately respond to accelerator input. Proper diagnostic steps should be taken to isolate these issues effectively. Drivers may notice several symptoms associated with DTC P2126. A primary symptom is that the engine may enter limp mode, where it operates under reduced power to protect itself from damage. In this state, the throttle may become unresponsive or react sluggishly to accelerator pedal input. This can significantly affect the vehicle's drivability, particularly in stop-and-go traffic or when trying to merge onto highways. Additionally, the check engine light on the dashboard will typically illuminate, serving as an alert to the driver that there is a fault that needs attention. These symptoms not only cause frustration, but can also lead to further complications if not resolved promptly. In this initial step, the focus is on verifying the APP Sensor B's voltage signal. To do this, first turn the vehicle to the on mode without starting the engine. Next, use the Honda Diagnostic System, HDS, to check the current voltage levels from the APP Sensor B. The threshold for this sensor's normal operation should be less than 0.2 volts. If the readings match this threshold, it indicates that the failure has been confirmed, leading to Step 3. If not, proceed to Step 2. This step is critical to gather baseline data about the sensor's current operational status and determine the appropriate course of action for further diagnostics. This step aims to identify intermittent failures of the APP Sensor B. Again, you will need to check the APP Sensor B voltage using the HDS. This time, the threshold to confirm an issue is set above 2.51 volts. If the sensor indicates values above this threshold, it confirms a problem. Subsequently, if no corroborative evidence is found, This points to an intermittent failure or an instance where the system is functioning properly. It's essential to inspect for potential loose connections or poor wiring at both the APP sensor and the PCM. Checking the onboard snapshot associated with this DTC may also provide insights into when and under what conditions the fault occurred. In this diagnostic step, you begin by turning off the vehicle and ensuring it is in the off-lock mode. Disconnect the APP sensor 6P connector to access the necessary points for your measurements. Subsequently, you will turn the vehicle to the on mode while keeping the APP sensor disconnected. Use a multimeter to measure the voltage between the designated test points on the APP sensor 6P connector. You are looking for a voltage measurement of approximately 5.0 volts. If you obtain this voltage reading, it confirms that the power supply is intact to the sensor, prompting you to move to step 4. Conversely, if the voltage does not register as expected, this suggests potential wiring issues that will require further attention. In this step, you will begin by turning the vehicle to the off-lock mode. Next, use the HDS to jump the SCS, System Communication Service Line, ensuring you wait for more than 1 minute to allow the system to stabilize. Once completed, disconnect the PCM connector A, 51P. Now, check for continuity between two designated test points, one in the APP sensor 6P connector and the other grounded body. Confirming continuity will indicate that there is a short circuit in the APS2 wire between the PCM and the APP sensor. If continuity exists, it suggests that this wire is indeed shorted and must be repaired. If no continuity is found, proceed to step 5 to assess for open wire issues. This step involves checking for any open wiring issues affecting the APS2 line. First, ensure that the vehicle is in the off-lock mode. Then connect terminals A and B at the APP sensor 6P connector with a jumper wire, specifically the terminal associated with the APP sensor, which should be grounded. Next, verify continuity between the PCM connector and body ground. This process will help isolate whether there are any breaks in the APS2 wire. If continuity is established, it indicates that the wire is intact, and you can proceed to step 6 for further diagnostics. However, if continuity fails, it implies a break in the wire that needs repairing to restore proper communication. In this critical step, you start by reconnecting the PCM connector A and ensuring the jumper wire is removed from the APP sensor 6P connector. Next, you will jump terminals A and B of the APP sensor 6P to perform checks for internal PCM circuitry functionality. With the vehicle turned to the on mode, utilize the HDS to measure the voltage. If the APP sensor B voltage is still registering below 0.2 volts, it suggests that an authorized service manual should be consulted for additional diagnostic information. Alternatively, you may consider substituting a known good PCM to see if the DTC P2126 clears. If this replacement resolves the issue, it confirms the PCM was indeed faulty and should be replaced. To continue troubleshooting the DTC P2126, initiate by putting the vehicle in the off-lock mode and jumping the SCS line with the HDS, allowing a stabilization period of over 1 minute. After this, proceed to disconnect the PCM connector A, 51P. The next step is to connect terminals A and B on the APP sensor 6P connector, with terminal A being grounded. Following this, you will check for continuity from the PCM connector A to body ground. Establishing continuity indicates the VCC5 wire is functioning properly, and you can move on to verify potential defects in the PCM. However, should you find no continuity, this points towards an open wire that would require immediate repair between the PCM and the APP sensor. In this phase of the troubleshooting process, you will turn off the vehicle and disconnect the APP sensor 6P connector once more. After powering the vehicle back to the on mode, the next step is to measure the voltage coming from 2 test points on the APP sensor 6P connector. The anticipated reading should be approximately 5.0 volts. If you confirm this voltage, it signals that the fault is indeed within the accelerator pedal module itself, and that it should be replaced. Conversely, if the measurement falls short, it signals that further investigation is required to identify issues that could point to other components. The clarity in this stage aids in isolating the issue effectively and determines whether replacement is necessary. The final troubleshooting step focuses on the SG5 line connections from the APP sensor to the PCM. Begin by setting the vehicle to the off-lock mode and executing the SCS line jump with the HDS, followed by a wait of over a minute for stabilization. Disconnect the PCM connector A, 51P, before jumping terminals A and B on the APP sensor 6P connector. After ensuring the appropriate connections, check for continuity between the PCM-A and body ground. Establishing continuity suggests the SG5 wiring is intact. If continuity is lacking, it indicates that the SG5 wire might be open, necessitating a repair in the wiring that connects the PCM and the APP sensor. Proper execution of this step will ascertain the source of the continued issues with DTC P2126. After completing the diagnostic and repair process for DTC P2126, it is critical to verify that the repair was effective. Start this verification process by ensuring that the vehicle is functioning normally again. Prior to any retesting, clear the DTC using the Honda Diagnostic System, HDS. Next, perform a driving cycle or series of tests to confirm that the problem does not reoccur. Monitor for any check engine light alerts and ensure there are no further safety triggers during operation. Observing that the vehicle operates without triggering the DTC again is the ultimate goal to ascertain that the repair was thorough and addresses the root cause of the initial issue. To prevent the reoccurrence of issues related to DTC P2126, it is advisable to engage in preventive maintenance practices. Regularly check the connectors associated with the APP sensor, ensuring they are clean, free of corrosion, and securely fitted. Aging wiring harnesses should be inspected frequently for signs of wear, fraying, or exposure, which could lead to electrical faults. Additionally, clean connections will ensure optimal conductivity, supporting accurate signals from the APP sensor to the PCM. Following these preventive measures can extend the life of critical sensor components and improve overall vehicle reliability. Implementing a routine maintenance schedule will aid in identifying potential problems before they escalate into costly repairs. In conclusion, the diagnosis of DTC P2126 calls for a methodical approach to identify potential issues with the APP sensor B. Recognizing the symptoms and understanding the diagnostic steps, from checking voltage levels to verifying wiring integrity, is vital for resolving this code efficiently. Each troubleshooting step provides clear insights into the electrical relationships within the accelerator pedal module and the PCM functionality. Following through with preventive maintenance recommendations will help in minimizing future occurrences of this DTC. Ultimately, a robust understanding of the system aids both technicians and vehicle owners in ensuring the reliable operation of the Honda Fit. Please like and subscribe to the channel. See you next time!